by Danny Grobler from Stillwater Critical Minerals. He couldn't make it in the end. Drilling is starting and so on and so forth. They are very active at the moment. They're very happy that Glencore has just last week agreed to buy into the project. So, you know, more important things for them to think about than giving a nice presentation at a conference, I suppose. But I will try to cover for them as good as I can. So Stillwater Critical Minerals is exploring the Stillwater complex since about a couple of years now, particularly the peridotite, the ultramafic portion of it that hasn't seen a lot of attention in the past. So we are here looking at Chrome Mountain, Iron Mountain area, wonderful part of the world, of course, most beautiful in Montana. Here we are just at the boundary, at the border between Montana and Wyoming. Stillwater complex. This map is from Modroo, one of Alan's many excellent papers, and beautiful colors. And this is a large layered intrusion, of course, one of the larger ones, although not in the top 10 globally, but it's a large layered intrusion here. And as you can see, it extends considerable distance towards the north, beyond cover. And Carol has shown us the geophysical evidence for this. Yeah, it was Carol. I'm getting confused with all these geophysicists and mixing up names there. So yeah, so you know, a large layered intrusion, and it is one of the most mineralized ones on Earth. In fact, the JM reef that Chris Jenkins is working on and showed us already and will show us more data is probably the most mineralized PGE reef on Earth. The grades are highest. It's a little bit less continuous than the Marensky reef or the UG2 chromatite, but the grades are definitely higher, compensating for this lack in continuity. I, of course, in this talk don't have time, you know, to go into depth into the Stillwater complex. There's no need. Other people have done that. It's been quite well studied. And Chris, of course, does a lot of work at the moment, together actually also with Stillwater Critical Minerals, USGS, and them work together quite closely. What I will do is I will highlight the key interest of Stillwater Critical Minerals, and that is the PG mineralization in the peridotite zone, which in the past has seen much less interest than that of the key reefs here, the JM reef, and then also the Picket Pin zone, which are the more well-known PGE reefs. So we are talking here in this talk, Stillwater Critical Minerals property is essentially the peridotite zone of the Stillwater complex, much less explored in the past. So we're talking about this interval here, also the bronzitite zone, but mostly the peridotite zone. That's where the Stillwater chromatites are located. And as I indicated in, I think it was a short course already, one of the major differences to the Bushveld complex is that at Stillwater, we have chromatites right from the base. In the Bushveld, they're coming in at, 500, 600 meters above the base. And even a little bit higher, but it's Stillwater, they're appearing right at the base. My suspicion was, or my suggestion was, perhaps it's related to the fact that certainly Stillwater Critical Minerals feels there are a lot of iron formation in the floor. Chris mentioned to me that he's not quite so convinced about this, but this could be a possible reason for the early appearance of chromite when I think about James Brennan's talk about the influence of banded iron formation on potentially stabilizing chromite early. Anyway, that's an important difference. There are some others that I come to in a moment. But other than that, lots of similarities to the Bushveld, as you can see, interlayered mafic, ultramafic rocks at the base. Then we're coming into gabbroic, interlayered gabbroic, troctolitic, and ultramafic rocks, the main reef mineralization 500 meters above that contact, typically in this sort of mafic, ultramafic transition zone. Big difference, of course, to Bushveld is we don't have the upper zone with magnetite layers at Stillwater. But other than that, lots of similarities. So what I'm going to focus is on the PG mineralization in the peridotite zone here at the base. And we have quite a bit of data actually on that already from Zintek and from Keyes and Lightfoot. But both Zintek and Keyes and Lightfoot, actually their data suggests that this peridotite zone is low-grade mineralized for PG. Here is the data from, that's in Woodrow's paper, but it comes from Keyes and Lightfoot. The data here you see PG up to a couple of tens of ppb, mostly up to about 100 ppb. That's about it, not higher. This is data from Zintek 2012 here at 2 localities. So you can see here PG contents go up to typically a couple of tens of ppb. And here towards the top, we're reaching perhaps 100, 200 ppb. Another intersection here, drill core intersection at Benbow, similar story. around 100 ppb maximum. So, you know, these data, the available data suggest that Stillwater is quite, the PGE contents in the ultramafic portion are quite low. Here again, this KEYS data, you see. So this is the ultramafic portion here until about here. So generally, actually very low PGE contents. You get the impression from these data, from these papers. So Stillwater, critical minerals, sorry for the busy diagram here from their website. So there's the Stillwater complex, there's the JM reef, there's the Picket Pin reef. So their property is in yellow here, the peridotite zone and the bronzitite zone. That's what their property covers. Going into the floor, to the floor. All right, so one of the reasons that made them optimistic, I guess, right from the beginning, and that made them confident this is underexplored and there's more to be found, is the soil geochemical data that indicate a lot of platinum, palladium, PGE, and copper nickel anomalies across the peridotite zone, across strike of the intrusion, essentially. And some of these are relatively recent discoveries here, for example, in the Pine area. So that is a good sign. This is a schematic diagram here of a profile through the intrusion. The little red dots, that is disseminated mineralization. So, you know, it is perhaps a little bit optimistic, but how do you want to show disseminated mineralization so that you can see it? So the little red dots, that's what indicates that we have mineralization, PGE mineralization, although, you know, highly variable grade throughout that peridotite and bronzitite zone and into the basal series. There is numerous meta-sedimentary xenoliths in the ultramafic zone of the complex here, indicated by these little brown fragments, and then the chromatite layers, of course. And I will show you briefly three types of mineralization, PGE mineralization, that we find in this zone. Firstly, we do have in the camp zone and other areas also net textured sulfides, pods of it and layers and lenses of it, here in this case about 10 meters wide. And, you know, several tens of meters along strike that contain here 1.5% nickel copper and 1 gram per ton PGE. So nicely net textured, disseminated locally, even massive sulfides here. That's in the camp zone. So that would be this sort of style of mineralization here in the basal series and the basal portion of the peridotite series. We do have what they call the hybrid zone. So the hybrid zone, they feel, is a sort of transgressive, intrusive Harzburgite dunite sills and dikes, perhaps, mostly sills that contain locally really elevated, highly elevated PGE. Here is an intersection of about 30 meters that runs on average, probably 2-3 grams per ton, with peak grades 5-6 grams per ton here. These are highly altered rocks, peridotites, lots of olivine, seemingly interstitial, intercumulus olivine between orthopyroxene crystals. So that's one of the typical things about the peridotite zone of the Stillwater complex. It's quite altered, actually, more altered than the bushveld, significantly more altered than the bushveld. So petrography and mineralogy is not quite as straightforward as in the bushveld. So that would be an example from the hybrid zone. Then we have chromatites. So as I mentioned, these things appear right from the base. And the most rich ones, the most PGE mineralized ones, that's another interesting thing, is actually the lowermost one, the AB chromatite. Whereas in the bushveld, these things, not only do they start coming in about 500, 600, 700 meters above the base of the complex, but the lowermost chromatites are actually very PGE poor. And the PGE content increases with height in the bushveld chromatites. Whereas here, it's pretty much the opposite. So you have very high grades here, 10 grams per ton. I'll show you an example in a moment, even higher at the bottom, and then much lower contents throughout the remainder of the chromatite seams. We don't understand this very well. Probably what this means is that magma reached sulfur saturation very early, presumably due to assimilation of the country rocks. The country rocks here are hornfelses. They are locally quite sulfide rich. And as I said, lots of banded iron formation, at least Stillwater critical minerals believe so. So that could be a reason. Here's an intersection from one of these chromatites. The actual chromatite is sitting here. You can see it's sort of it's not perfectly visible. This sample they have taken to their head office to show it investors. That runs at about 15 grams per ton here. But I analyzed, and I did with Sarah and Shikudimi, because this is all, you know, a commercial assay, and I want to be 100% sure we analyze this thing in Shikudimi here. It's quite strongly altered, running at 20 grams per ton. So, you know, these are really very, very high grades. And so it seems that not just the JM reef is richer than equivalent reefs in other late intrusions, the chromatites appear to be richer. Although yesterday at the poster session, I saw this amazing chromatite from the Brazilian group. I can't remember the intrusion now, that run at what, 40 ppm or something, unbelievable. So there you go, really quite exciting mineralization. And so Grobler and his team, they have produced this diagram summarizing the types of mineralization at Stillwater, comparing it to the Bushveld and the Bushveld Platte Reef. So broadly speaking, as I said, the stratigraphy looks quite similar. Ultramafic, layered ultramafic rocks, then layered mafic ultramafic rocks, the reefs, the main reef sitting at more or less the same stratigraphic horizon. But at Stillwater, it seems that the ultramafic zone, the peridotite zone, is more mineralized than in the Bushveld complex. Certainly in the main portions of the Bushveld, the western and eastern lobes. In the Platte Reef, as you know, the Platte Reef and the Flood Reef, we have more significant sulfide mineralization also in the ultramafic rocks that many people correlate to the lower zone. So yeah, that's it. So this is the last picture here. This is a wonderful area, of course, to work in. This is in the Chrome Iron Mountain area here, looking onto the Beartooth Mountains. So wonderful place to do geology.
Brought us back on time. So
yep.
Any questions?
Just out of curiosity, you describe those as intrusive dunites. Are they actually magmatic intrusive, or are they replacement dunites?
Well, yeah. So yeah, so you're right. Actually, I think the past workers have have called these things replacive dunites. That's true. So you could argue that how precisely that replacement has happened is a matter of argument, but of course, Alan wants them to be, reactive dunites. So that's I don't have fundamentally an argument with that. That's quite possible that that's what happened. Yeah.